The last thing we're going to talk about in this section is how to evaluate inverse trigonometric functions on a calculator. You will need to know this in case you're solving an equation and you've got to get a decimal approximation for the solution, or if you're working on a word problem and again you've got to get a numerical answer out. So they can be a bit tricky because, as it states in the first bullet point, your calculator does have buttons for sine inverse, cosine inverse, and tangent inverse, but not for the other three inverse trig functions. Okay, so if we look at the calculator, basically, if you see where my arrow is, I see sine, cosine, and tangent. And if you look above them, you will see the inverse functions. So if I want sine inverse, it's blue. So I'd have to hit the blue second key and then hit sine, and then that will bring up sine inverse. Same thing for cosine inverse and tangent inverse. But there's nothing there for cosecant inverse or secant inverse or cotangent inverse. So we really need to talk about those. So remember that basically I'm going to go ahead and bring this part up. When you plug into an inverse trig function, you're going to plug a number in and the output is going to be an angle. So it depends on what you want. Do you want your angle returned in degrees? Well, if so, your calculator needs to be in degree mode. If you want the angle instead returned in radians, then your calculator needs to be in radian mode. So basically, whether your calculator needs to be in degree mode or radian mode just depends on how you want the angle returned. Okay, so let's talk about how you are going to deal with cosecant inverse, cotangent inverse, and secant inverse. So that is summarized in these two bullet points right here. So I'm not going to get into why we have to enter it this way because your book only goes into punching in decimals, okay? So if we actually had some fractions involved, I could kind of explain to you why we have to input the values this way. But again, since your calculator's having you practice on decimals, I'm not going to be able to show you. So I'm just going to tell you the proper protocol for punching in these three remaining trig inverses, okay? To do cosecant inverse and secant inverse, those are going to be treated similarly. So to evaluate cosecant inverse of x, you're going to punch that in as secant inverse of 1 over x, okay? And this is the x value, okay? So that's how you're going to handle that. You're going to do the same thing for secant inverse of x. You punch that in as cosine inverse of 1 over x, okay? So this value is this value, okay? Cotangent inverse is a bit strange, okay? You have to pay attention to whether or not the number you're taking the cotangent inverse of is positive or negative. You're going to do one thing if the value of the number that you're taking the cotangent inverse of is positive, and you're going to do a slightly different thing if you're evaluating a negative number, okay? So if the number you're taking the cotangent inverse of is positive, that's this first case, you're going to do just what you did for cosecant and secant, okay? So it's going to be the tangent inverse of 1 over x. However, if the quantity you're evaluating, if the x value is negative, you have to do that calculation tangent inverse of 1 over x, but then you have to add 180 degrees to ensure that you end up in the right quadrant, is essentially what's going on there, okay? So these are the protocols you need to follow for evaluating inverse trigonometric functions on your calculator. Okay, so let's do some practice here. In example 7, we are going to use a calculator to approximate each value in decimal degrees. Okay, so we're doing a lot of practice, and some of that is coming from having to deal with the weird cotangent guy. Okay, so notice here, each one of these, we have some kind of inverse trig function. We're plugging in a number and it's returning an angle theta. We're trying to figure out what this angle theta is, okay? So according to the directions, we should be spitting out an angle in degrees. So I'm going to pull up my calculator. I'm already set to degree mode, which is good. Okay. I am going to try to configure this thing so I can fit it in the same screen as the video here. Let me see. Hang on, let me pause the video for a second. Okay, I'm back so we can see things side by side here. I've got the calculator in degree mode because the directions ask me to return a degree angle. So here we go. In part A, we're evaluating an arcsine. So all we have to do is call up second inverse here, or sine inverse, and then just punch the number in. Okay, exactly like you see it. Okay, nothing crazy. Okay, very, very straightforward. Okay, so I'm going to go ahead and write down the full decimal expansion. So remember, this is going to be a number in degrees. Okay, so let's write this down. This is going to equal 51.169.12193 degrees. Okay, so that is your degree measure for that particular angle. Okay, again, nothing fancy. Okay, let's move on to secant inverse. Okay, so secant inverse is one of the crazy ones because you don't have a secant inverse button. Okay, so go up here to the rule. You're going to evaluate this guy as the cosine inverse of 1 over the number. Okay, so this is going to be, what you need to put in the calculator is the cosine inverse of 1 over the number here, like this. Okay, so this is what we're going to pop into the calculator. We are in degree mode. Okay, so that means a degreed angle will be returned. So we're going to hit the cosine inverse of 1 over this negative 5.1180378. Okay, so this is how you evaluate secant inverse. Okay, again, I will write down the full decimal expansion here. This is going to be 101.2673542 degrees. Okay, that's it. Okay, all right, what is next? The next guy is going to be the cosecant inverse of 1.9422833. Okay, again, cosecant inverse doesn't have a button. We have to follow the rule up here. Very similar to what we do for secant inverse. We just use sine inverse instead of cosine inverse. So what we will plug into the calculator here is going to be the sine inverse of 1 over our number. Okay, so let's pop this in. Okay, this is going to be the sine inverse of 1 over 1.9422833, and out comes our angle in degrees, 30.9879607 degrees. Okay, so that's it. Okay, so you're just following the rules here. Okay, parts D and E, here come the cotangent guys. Okay, so we're going to do the same kind of thing. It's basically tangent inverse of 1 over the number, but you do have to take an additional step if the number you're taking the cotangent inverse of is negative. So that's going to happen in part E. So let's do part D first. So you're going to enter this as tangent inverse of 1 over the number. Okay, so let's pop this in. This is going to be tangent inverse of 1 over 1.7670492. Here comes the angle, 29.50618.107, that many degrees. Okay, So really the only confusing time is when you are taking the cotangent inverse of a negative quantity like you do here. You're going to do the same thing we just did. So you're going to do the tangent inverse of 1 over the number. Okay, but then according to the rule, if your argument is negative, you need to add 180 degrees to the result. So once we get this number, we are going to have to add 180 degrees. Okay, so let's do it. This is going to be 1 over the, this is going to be the tangent inverse of 1 over negative 2.7733744. Okay, so this is a degree measure, but we need to add 180 to it to make sure we're in the correct quadrant. Okay, so this angle measures 160.1721369 degrees. Okay, so these were just lots of examples of doing degree angles. Okay, in example 8, it's going to be the same thing, but the directions are going to be a little different because you're going to want the angle measured in radians. So in your book, the directions are going to say use a calculator to approximate each real number value. And that's all they say. Out to the side in italics, they say be sure the calculator is in radian mode. Okay, so I'm going to go to my calculator and I'm going to switch over to radian mode. Okay, so now my angles are going to be in radians. So you're not going to get something like pi over 3 out or pi over 4. You're going to just get a decimal. Okay, so that's what you need to anticipate. So let's give this a shot. Okay, so for part A, we're doing the arc cosine of this decimal. So the rule says it's the same rules, whether you're in degrees or radians. We are going to punch in our rule. Okay, so if you just need to revisit this, well, remember, sine, cosine, and tangent inverses, you just punch the button in. So let's see, we're going to do inverse cosine of this entire decimal quantity. Okay, so here we go, and this will be the answer. It will be in radians. Okay, so it's okay. Do not put a degree symbol. If you put a degree symbol, then that means the angle is in degrees, and it is not. Okay, so here it is. Okay, just leave it as a number. If it makes you happy, put rad at the end for radian. Okay, but usually radians are considered to be unitless. Okay, all right, so next we've got an arctan of this decimal. Okay, so again, you just need to use your inverse tangent button here. There are 1, 2, 3, 4, 5, 6, 7 ones after the decimal point. So let's punch that in. This is going to be inverse tangent of, let's see, 1, 2, 3, 4, 5, 6, 7. Oops. There we go. Okay, so here comes our angle. Okay, this is 0.8379 blah, blah, blah radians. I hope you remember what a radian measure is. Okay, basically, think of your unit circle. Think, well, not necessarily the unit circle. Say you have a circle and you take the radius. If you take the length of the radius and lie it along the circle itself, like imagine a piece of string, you hold a piece of string very tight along the radius to measure it, and then you move that piece of string to lie it along the radius. It's basically how many radii you're getting, and that's going to make your angle. Okay, so this particular measure of this many radians, 0.837 and so on, you're not going quite one radius around the circle, just short of that. Okay, all right, so we did that one. Now we've got to deal with the two crazy cotangent, guys. Okay, so let's do cotangent. We're going to do it just like we did before. This is going to be the tangent inverse of 1 over the number. We have a positive argument in part C, so we don't have to do anything additional here. We just need to punch this guy in. Okay, and I need to go ahead and write this down that this is what I did here. This is going to be 1 over the, or sorry, I keep writing the wrong thing. This is going to be tangent inverse of 1 over the number, and that is all we have to do. And let me just write down the answer here. This is going to be 0.7835 729 529. Okay, that many radians. Done. Okay, part D is the tricky case where you're taking the cotangent inverse of a negative argument. So all you have to do again is do tangent inverse of 1 over the number, but this time, since the argument is negative, you have to take the result and you have to add 180 degrees to it. Okay, that's if you're in degrees. Okay, so since we're in radians, we have to add the equivalent in radian measure. So 180 degrees is the same thing as pi radians, so that's what we need to add to this quantity. Okay, so let's compute it. This is going to be the tangent inverse of 1 over negative 36.874610. Okay, so take this quantity and then you have to add pi. If you add 180, it is going to be wrong. And I don't know why this is giving me an exponent here. Okay, delete. Okay, plus pi. Okay, there we go. Okay, so the correct angle here in radians is 3.114480368. Okay, so if you had your circle and you measured the radius, okay, you would go around the circle like it's an arc length of just over 3 radii, essentially. Okay, so that is your value, and you are done. We are done with these. Okay, so keep this sheet of paper handy, okay, with these rules for evaluating inverse trigonometric functions, particularly for the cosecant inverse, secant inverse, and cotangent inverse.